Welcome back to Legends in the Spotlight, where we explore, the captivating lives and revolutionary work of physics' most influential figures.
Yeah, from the pioneers who shaped like the very foundations of modern science to the trailblazers pushing the boundaries of our understanding today, we unravel the remarkable discoveries and ideas that have reshaped our perception of the universe.
Get ready to dive deep into the stories behind the theories, the people behind the equations, and the enduring legacy of these brilliant minds who dared to imagine beyond the limits of the known.
So if you're ready to embark on a journey of scientific exploration, and be inspired by the giants whose shoulders we stand on, you've come to the right place.
Today, our spotlight shines on none other than Albert Einstein, a name synonymous with genius, but whose life story holds so much more than just equations.
Yeah, his journey is a tapestry woven with intellectual curiosity, unwavering perseverance, a profound impact on science and humanity, and a touch of rebellion that makes his story all the more captivating.
Okay, let's unpack this, starting with Einstein's early years.
Hmm.
It's fascinating how someone who became a global icon of genius wasn't always recognized for his academic brilliance.
Yeah, it's almost like his early struggles in school fueled a lifelong skepticism of rigid systems. Like he excelled in math and physics, but other subjects just weren't his forte.
Right, right. And there's that famous story about him renouncing his German citizenship at 16 to avoid military service. Even as a teenager, he was charting his own course.
That independent streak really shines through. It's as if he sensed there was like a different path for him, one where he could follow his own curiosity.
And speaking of curiosity, one event stands out as a pivotal moment in sparking his lifelong passion for the unseen forces that govern our world. A simple compass.
Ah, yes, the compass story. It's said that young Albert, only 5 years old at the time, was utterly mesmerized by the way the compass needle moved, seemingly guided by an invisible force.
I can almost picture him, staring at that compass needle, completely absorbed in the mystery of it all. What do you think it was about that experience that sparked such a lasting fascination?
Perhaps it was the realization that there's so much more to the world than what we can see with our own eyes. That there are unseen forces at play shaping the reality around
Like
us.
that compass opened a door for him, a glimpse into a world of hidden wonders, waiting to be explored.
And then at age 12, he discovered a geometry book that further fueled his academic fire. He called it his holy geometry book. That's quite a testament to the impact it had.
Imagine a 12-year-old calling a geometry book holy. It speaks volumes about his early passion for the elegance and logic of mathematics.
It was like he had found a language that resonated with his way of thinking, a way to unlock the secrets of the universe.
And let's not forget his self-taught mastery of calculus,
Mm.
around the same time. That's pretty remarkable for someone so young. It really highlights his natural aptitude for complex mathematical concepts.
Absolutely. It shows an innate drive to delve into the depths of knowledge, a willingness to go beyond what was being taught in a conventional setting.
So we see this young Einstein, with a burning curiosity, a love for math and physics, but his path to higher education wasn't exactly straightforward.
Right, right. He initially failed the entrance exams for the Swiss Federal Polytechnic School in Zurich. He was younger than the typical applicant, and while he excelled in math and physics, other subjects held him back.
It's interesting how even someone like Einstein faced setbacks early on. It kind of makes him more relatable, don't you think?
Absolutely. It reminds us that the path to success is rarely linear. Even the brightest minds can encounter hurdles along the way.
So he spent a year at a Swiss cantonal school, honing his skills, broadening his knowledge, and ultimately gaining admission to the Polytechnic in 1896.
What's fascinating is how this period of redirection may have actually benefited him in the long run. By stepping outside the traditional academic path, he had the opportunity to explore his interests more broadly and develop his own unique way of thinking.
That's a great point. It's like those early detours helped him cultivate the independent thinking that would later lead to his revolutionary breakthroughs.
It's a reminder that sometimes the path less traveled can lead to the most extraordinary destinations.
Now, we can't talk about Einstein without diving into his miracle year of 1905. At just 26 years old, he published four groundbreaking papers
Hmm.
that that fundamentally changed our understanding of the universe.
It's truly mind-boggling to think about the sheer volume and significance of the work he produced in that single year. It's a testament to his incredible intellectual prowess and his ability to see the world differently.
Let's break it down, starting with his paper on the photoelectric effect. At the time, the prevailing view was that uh, light behaves solely as a wave, but Einstein proposed something radical. Light could also behave as a particle.
Imagine a tiny grain of sand. Now imagine that grain of sand carrying the energy of 1 million tons of TNT. That's what Einstein showed us with his concept of light quanta, later called photons.
Wow. That's a powerful analogy. So he's saying that light isn't just a continuous wave, but it also comes in these discrete packets of energy, like tiny bundles of pure power.
Exactly. And this revolutionary idea not only explained the photoelectric effect where electrons are emitted from a material and light shines on it, but it
Yeah.
also laid the foundation for quantum
Look,
mechanics.
quantum mechanics governs the behavior of matter and energy at the atomic and subatomic level. It's like the rule book for the tiniest particles in the universe, and it all started in part with Einstein's insight into the dual nature of light.
His work on the photoelectric effect earned him the Nobel Prize in Physics in 1921. Imagine that. A Nobel Prize for an idea that initially met with resistance from the scientific community.
It highlights how groundbreaking his ideas truly were. He was challenging the very foundations of how we understood light and energy.
And it's a testament to his courage to stand by his convictions even when they went against the prevailing scientific wisdom.
Just a few weeks after publishing this groundbreaking paper on the photoelectric effect, Einstein followed up with another remarkable piece of work, this time focusing on a phenomenon known as Brownian motion.
Brownian motion refers to the seemingly random, jiggling movement of particles suspended in a fluid like pollen grains dancing in water.
It's a phenomenon that had puzzled scientists for decades, but Einstein, using his unique perspective and mathematical prowess, was able to develop a theoretical explanation.
He showed that this seemingly chaotic dance of particles was actually a direct result of the constant collisions between these tiny suspended particles and the even tinier invisible atoms and molecules making up the fluid.
So he's saying that these tiny particles are constantly being bombarded by even smaller particles that we can't even see.
Precisely. And this constant bombardment creates the jittery motion we observe as Brownian motion. It was a brilliant insight that provided concrete evidence for the existence of atoms and molecules, which was still debated at the time.
It's amazing how he was able to connect these seemingly disparate phenomena, the photoelectric effect and Brownian motion, and reveal a deeper underlying
Right.
principles.
It speaks to his ability to see connections that others missed, to weave together seemingly unrelated threads into a coherent tapestry of understanding.
And this was all still within his miracle year.
Right.
We've only just scratched the surface of what he accomplished during this incredibly productive period.
Welcome back to Legends in the Spotlight, where we're continuing our exploration of the extraordinary life and work of Albert Einstein.
Last time we left off with Einstein in the midst of his miracle year, having already published two groundbreaking papers that challenged the prevailing scientific views on light, matter, and energy.
But he wasn't done yet. In that same year, he published two more papers. One introducing the world to the mind-bending concept of special relativity, and the other revealing the famous equation E-mco.
Okay, so special relativity. This is where things get really interesting, right?
It definitely is. Special relativity challenged the very foundations of Newtonian physics, which had been the accepted model for centuries, by proposing that time and space are not absolute, but are relative to the observer's frame of reference.
Hold on. Time and space are relative. What does that even mean?
Well, imagine you're on a train traveling at a constant speed. Inside the train, everything seems normal. Time flows as usual, and the laws of physics behave as you'd expect. But to someone standing outside the train watching you whiz by, things appear differently.
So the person on the train experiences time differently than the person standing still.
In a way, yes. That's the essence of special relativity. Time and space are not fixed and unchanging, but can be stretched and compressed depending on your relative motion.
So it's all about perspective. Like your experience of time and space is relative to your own movement.
Exactly. And one of the key postulates of special relativity is that the speed of light in a vacuum is constant for all observers, regardless of their own motion.
So no matter how fast you're moving, even if you're traveling at the speed of light, you'll always measure the speed of light to be the same.
That's right. It's a mind-boggling concept, but it's been experimentally confirmed time and time again.
So if the speed of light is constant, then something else has to give. And that's something is our perception of time and space.
Precisely. Special relativity tells us that as you approach the speed of light, time slows down and distances contract relative to a stationary observer.
It's like something out of a science fiction movie, but it's real.
Absolutely. The implications of special relativity are profound. It reshaped our understanding of the very fabric of the universe and paved the way for groundbreaking technologies like GPS, which relies on precise timekeeping to determine location.
And then there's the famous equation that emerged from special relativity, the one that has become synonymous with Einstein's genius, EMC time.
Ah, yes. The equation that expresses the relationship between energy, mass, m, and the speed of light. See,
So what does that equation actually tell us? I know it has something to do with mass and energy being interchangeable, but I've never fully grasped the meaning.
it's essentially a recipe for converting mass into energy, and vice versa. It tells us that a tiny amount of mass can be converted into an enormous amount of energy, and conversely, that a huge amount of energy can be concentrated into a small amount of mass.
So that's why nuclear weapons are so powerful. They're essentially converting a tiny amount of mass into a massive release of energy.
Exactly. EM unlocks the incredible power hidden within the very building blocks of matter. It's a concept that has had profound implications both in our understanding of the universe and in the development of technologies that have shaped our world.
Einstein's fourth and final paper from his miracle year delved even deeper into this mass-energy equivalence, exploring its implications and further solidifying the connection between these two fundamental concepts.
And as we'll see later, this groundbreaking insight would have both positive and negative consequences, shaping the course of history in ways that Einstein himself couldn't have foreseen.
It's amazing how this one year, 1905, was such a turning point, not only in Einstein's life, but in the history of science. It's like the world shifted on its axis.
It truly was a period of unparalleled intellectual creativity and groundbreaking discoveries.
But despite the revolutionary nature of his work, Einstein still faced challenges in his academic career. After graduating from the Polytechnic in 1900, he struggled to find a teaching position.
Imagine that. One of the most brilliant minds of the 20th century struggling to secure a job in academia. It's a reminder that recognition and success don't always come easy, even for someone with extraordinary talents.
It's also interesting to consider how this period of uncertainty may have shaped his thinking. He wasn't bound by the constraints of a traditional academic setting, which allowed him the freedom to pursue his own ideas outside the mainstream.
That's a great point. Sometimes the path less traveled can lead to the most unexpected breakthroughs.
So he ended up taking a job at the Swiss Patent Office in Bern in 1902, a position he held for 7 years while continuing his scientific research in his spare time.
It might seem like a mundane job for a budding theoretical physicist, but some believe that his experience at the patent office actually influenced his thinking in unexpected ways.
In what way?
Well, reviewing patent applications required a keen eye for detail, a deep understanding of how things work, and a knack for visualizing complex concepts in 3 dimensions.
It's fascinating to think how those skills honed in the seemingly ordinary setting of a patent office might have contributed to his extraordinary ability to envision the workings of the universe.
It's a testament to the interconnectedness of knowledge and experience, and how seemingly unrelated fields can sometimes inspire unexpected breakthroughs.
So while working at the patent office, Einstein's mind was still ablaze with ideas, and he continued to push the boundaries of scientific understanding.
His work on special relativity, groundbreaking as it was just the beginning. He was already grappling with a new set of questions that would lead him to his masterpiece, the general theory of relativity.
General relativity took Einstein another decade of intense thought and mathematical exploration to develop.
It was a journey marked by both intellectual struggle and moments of pure exhilaration as he pieced together a new framework for understanding the universe.
And it all started with a simple question. If If a person falls freely, they don't feel their own weight. Why is that?
This seemingly obvious observation sparked a chain of thought that would lead Einstein to revolutionize our understanding of gravity. He realized that gravity and acceleration are, in a sense, equivalent.
Wait, so if I'm in an elevator accelerating upwards, it would feel the same as if I were standing still in a gravitational field.
Exactly. That's the essence of the equivalence principle, one of the cornerstones of general relativity.
So how does this connect to gravity?
Einstein used the equivalence principle to develop a theory of gravity that went beyond Newton's ideas, explaining gravity not as a force, but as a curvature of space-time.
Curvature of space-time. What does that mean?
Imagine a bowling ball placed on a trampoline. The ball causes the trampoline to sag, creating a dip. Now imagine a marble rolling across the trampoline. The marble's path will be curved as it follows the dip created by the bowling ball.
I'm starting to see the picture. So in Einstein's theory, massive objects like the sun warp the fabric of space-time,
Yeah.
creating a kind of gravitational well that causes other objects to move towards them.
Precisely. It's not that the Earth is being pulled towards the sun by a mysterious force, but rather that it's following the curvature of space-time created by the sun's mass.
That's incredible. It's like the sun is creating a cosmic highway, and the Earth is just cruising along, following the curves.
And this curvature of space-time isn't limited to just massive objects. It affects everything, even light.
So that's why light bends around massive objects like stars. It's following the curves of space-time.
Exactly. General relativity predicted that light from distant stars would be deflected by the sun's gravity, and this prediction was confirmed during a total solar eclipse in 1919.
That must have been an amazing moment for Einstein to see his theory validated by observation.
It was a pivotal moment in the history of science. It catapulted Einstein to international fame and cemented his place as one of the greatest minds of all time.
So general relativity explains everything from the bending of starlight around massive objects to the expansion of the universe itself. It's truly a revolutionary theory.
It's a testament to the power of human curiosity and the incredible insights that can emerge when we dare to question our assumptions about the nature of reality.
Einstein's journey, however, was far from over. He continued to explore new frontiers in physics and engaged in lively debates with his contemporaries about the implications of his discoveries and the emerging field of quantum mechanics.
And as we'll see in the next part of our show, this exploration led him to question some of the very foundations of quantum mechanics, even as his own work had helped to pave the way for this revolutionary new field.
Welcome back to Legends in the Spotlight.
Yeah.
It's incredible to think about all that Einstein accomplished, by his early 40s. But as we'll see, his later years were filled with new challenges, both personal and scientific.
That's right. While Einstein enjoyed global fame for his groundbreaking work on relativity, he also wrestled with the implications of his discoveries, especially as the world, descended into another devastating war.
And he became increasingly vocal about social and political issues, advocating for peace, civil rights, and international cooperation.
It's as if he recognized the power of his voice and felt a responsibility to use it for something beyond the realm of science.
One area where he became particularly active was in the debate surrounding quantum mechanics, the theory that governs the behavior of matter and energy at the atomic and subatomic level.
It's fascinating how Einstein, who had played a key role in the early development of quantum theory, ended up being one of its most prominent critics.
It seems counterintuitive, right? You'd think he'd be thrilled to see this new field emerge, but he actually had deep reservations about some of its core principles.
It all came down to the concept of randomness. Quantum mechanics introduced the idea that at the most fundamental level, the universe is inherently unpredictable.
So instead of everything being determined by cause and effect like a clockwork universe, quantum mechanics suggests that there's an element of chance involved.
Exactly. And this idea troubled Einstein, deeply. He famously declared God does not play dice, expressing his discomfort with the notion of a universe governed by probability rather than strict determinism.
I guess it goes back to his belief in the elegance and order of the universe It's hard to reconcile that with the idea of random events at the subatomic level.
And it's important to remember that Einstein's skepticism wasn't a rejection of quantum mechanics altogether. He recognized its predictive power and its ability to explain experimental results.
So it was more about his philosophical interpretation of what the theory meant about the nature of reality.
Exactly. He believed that a deeper, more complete theory must exist, one that would restore order and predictability to the subatomic realm.
This debate between Einstein and the proponents of quantum mechanics like Niels Bohr is one of the most famous in the history of science.
Yeah.
It really highlights the fundamental questions about the nature of reality that these theories raise.
And it's a debate that continues to this day, even though many aspects of quantum mechanics have been experimentally confirmed.
It's a reminder that even the greatest minds can grapple with uncertainty and that the search for truth is an ongoing process.
Now, as the political landscape in Europe darkened in the 1930s with the rise of Nazi Germany, Einstein's life took a dramatic turn.
The Nazi Party, with its ideology of racial purity and its virulently anti-Semitic views, posed a direct threat to Einstein, a Jewish scientist of international renown.
It's a chilling reminder of how quickly hatred and intolerance can poison a society, and how even the most brilliant minds can become targets of persecution.
In 1933, while Einstein was visiting the United States, Hitler came to power in Germany. He realized the danger of returning to his homeland and made the difficult decision to stay in America.
It was a loss for Germany, but a gain for the United States. He accepted a position at the Institute for Advanced Study in Princeton, New Jersey, and became a permanent resident of the country.
Imagine the impact of having someone like Einstein arrive on your shores, a refugee fleeing persecution, but also a global icon of genius.
It's a testament to the power of inclusivity and the importance of providing a haven for those seeking refuge from tyranny.
Einstein continued his scientific pursuits in America,
Yeah.
still searching for that elusive unified theory, but he also became increasingly involved in social and political activism.
He understood that his fame gave him a platform, and he felt a responsibility to use it to speak out against injustice and advocate for peace.
He was a strong supporter of the civil rights movement in America and spoke out against the dangers of nuclear proliferation, especially in the wake of the atomic bombings of Hiroshima and Nagasaki.
Those events weighed heavily on him, as he had played a role, however indirectly, in the development of the atomic bomb by signing that letter to President Roosevelt in 1939.
It must have been a heartbreaking realization that his equation, E=mc Fisher, which had unlocked so much potential for understanding the universe, had also been used to create such devastating weapons.
It's a stark reminder that scientific progress can have both positive and negative consequences, and that scientists have a responsibility to consider the ethical implications of their work.
Einstein spent the remaining years of his life advocating for peace and urging world leaders to find ways to control the spread of nuclear weapons.
He believed that science should be used for the betterment of humanity, not for its destruction, a message that resonates even more strongly today.
Now, even with all the fame and the weight of the world on his shoulders, Einstein never lost his sense of humor or his love for the simple things in life.
There are countless stories about his witty remarks, his fondness for sailing, and his passion for playing the violin. He was a complex and multifaceted individual, a genius, but also a deeply human and relatable figure.
In his later years, he continued to work on his unified theory, although it ultimately remained unfinished. He never gave up on the pursuit of knowledge and understanding.
And that's perhaps one of the most inspiring things about Einstein, his relentless curiosity, his willingness to keep asking questions, even when the answers seemed elusive.
He showed us that the journey of discovery is just as important as the destination, and that the true measure of a scientist is not just their intellect, but also their heart and their commitment to making the world a better place.
Albert Einstein passed away in 1955 at the age of 76, leaving behind a legacy that continues to inspire and challenge us today.
He was more than just a brilliant physicist. He was a humanitarian, a philosopher, and a symbol of the boundless potential of the human mind.
His story reminds us to embrace curiosity, to question our assumptions, and to never stop striving for a deeper understanding of ourselves and the universe we inhabit.
We hope you've enjoyed this exploration of Albert Einstein's life and work. He was truly a legend in every sense of the word.
And if his story has sparked any thoughts or questions, we encourage you to share them in the comments below. We'd love to hear your reflections.
Don't forget to like and subscribe to our channel for more captivating deep dives into the lives of the legends who shaped our world. Thank you for joining us on this journey.